So yes, proceed with the questions.
Hello, everyone. Hello, everyone. So we are with Venkatesh today, and we are going to take a few questions as he's a big data engineer in one of the company called Walmart, right?
Yeah.
Yeah. So we are going to take few questions which we had and which we have been struggling and we wanted to know about. So Venkatesh, can I ask you some questions if you are ready with? So yeah,
Yeah, sure. Go
This
ahead.
is a part of our course curriculum. So we have to
Okay.
view a big data engineer and ask some questions about the industry, how it's different from like how it's different from studying in class and different aspects of big data as well.
Okay. What course is this?
Big data for analytics.
Big data for analytics. Okay.
So the assignment is to interview an industry expert.
Okay.
But we'll just ping you.
Hmm.
Okay.
so I was thinking of asking these questions. So one of the questions which I had and I was thinking of is like currently we are working on different algorithms called like BGMI and ASM. So my question is, what are the different algos you are currently working on and or came across, and how did those algorithms help you in your coursework? I mean, in your work, in your projects and your work.
So, can you repeat what these algorithms are? Again?
Like DGIM algorithm, right?
These are the stream counting
String
algorithms.
counting
String
algorithms.
counting algorithms. So we haven't come across any string counting algorithms as such. So on a day-to-day basis, we usually do deal with a lot of ETLs. So you
Mhm.
get a data in raw form. You have to
Okay.
process them through multiple filters. You have to aggregate them. So as such, we do our custom filterings. So whenever there are tons of TVs of data flowing in, and you just want to
Mhm.
pull out one customer's record, so those sort of scenarios we deal with.
Okay.
So we, if you don't have any Spark or any parallel execution algorithm already prepared, we always go for custom algos. So
Mhm.
we uh, find a way to find only the file-based approach. So if you have a million files a day, and if you're
Mhm.
looking for one customer, so you have to see the ratio of how it would be. So we go more of extracting those files. So most of what I deal with is custom-based approach. So we don't use any filterings, Bloom filters or anything as such.
Thank you.
So,
Yeah.
like, what are big data technologies or tools that you use for your work, like most often?
Okay.
Any?
Hmm.
Yes. So we use a lot of Apache Airflow for scheduling. Most of our job, so I work as a data engineer for privacy compliance. So that means whenever a customer wants to see their data, so we have to pull data for that customer out of the huge data that we have available so far. So to do that, we have our Spark submit jobs, your shell script files or whatever that you want to run. We use a framework called Apache Airflow. So everything is coded in Python. So you can do ETL, you can have dependencies on other DAGs. Like let's say you're running a process to load your data, and there is some other process that has to wait until this process finishes. So Apache Airflow is a really handy tool that way. You can have sensors. You can have one DAG start before the other DAG finishes, or it will wait until the other DAG finishes. Those sort of things. So Apache Airflow is a really good tool for scheduling, and you can always connect any compute on your Airflow. You can have your Databricks run on your Airflow. You can have just your Azure VMs connected. So any compute you can connect to Apache Airflow. So as for computing, we use Airflow, and for mostly visualization, we use a lot of Looker. So I don't know if you have heard of Looker.
Hmm?
So
Which
Looker,
tool is that? Looker.
so Looker. So Google has a application called Looker. You can have any number of panels to project your data. So it can be aggregated, it can be linear, whatever. But the good thing about Looker is you can connect Looker to any sort of database that you can think of. So it can be your Hive, you can have Trinity. there are a lot of underlying data which resides either in your Google storage, your Azure, or say your Amazon.
Three buckets.
Connect to Looker. So yeah.
Yeah. What are the challenges you encounter in day-to-day basis for right from ingestion till like the place where you use the data, like in this pipeline? What are some of the bottlenecks or things that you find?
Okay. So whenever will be asked to project these dashboards on Looker, we always ask for what exactly is their need. So are they looking for the raw ingestion part? Are they looking for the ETL's last part? Because usually business folks don't really care about the raw data that they get directly from the customer's records or whatever. So it's usually ETL on top of ETL on top of ETL. So it's basically KPIs. For example, someone will come and say that, hey, you know what? In Sunnyvale area, I want to see how many customers purchase product X. In California, as such, how many people have purchased a product. So the sort of aggregates they are looking for. So these aggregates once go through the whole day's ETL, having dashboards on it because there is a lot less data. But if say you want to have dashboards on your level zero, like the raw data that you have, there are millions of transactions that are happening on a day-to-day basis. So those, if someone is asking for it, that will be a challenge. So because you can't connect a slow moving database, slow moving files to Looker and stuff. So we always advise them, you know what, get a clear cut use case, what you're looking for. Let us do the aggregates by using Spark and whatever. Then we'll proceed to do the dashboards in the final layer.
Okay. What kind of data governance policy or security challenges you face day to day life, and how do you like navigate those things?
Okay, so let's say us being privacy team, will be asked to enforce certain restrictions on what is the data that we are posting to back to customer as well. So we can't just be sharing their credit card information, everything over the email just because they asked for it. But customer can actually request what data Walmart is collecting on for them. You can just scroll to walmart.com, scroll all the way down. There is an option called request my info. So uh, all the Walmart teams extract the personal information from the customer, they consolidate and send it back to the customer, but it will be sent as a PDF file over email. We have to put a lot of checks in place, making sure that we are not sharing any personal information, no matter how securely shared with the customer, is present in that PDF report. So we have a database called Cosmos, and whenever someone is posting to our API, we always make sure that for them to follow certain conditions, that if you are posting your credit card information, make sure it is masked. Even address, nothing that we are communicating customer should have any identifier that can be backtracked to the customer to exact geolocation or anything. So those things will be set in place by us and will be enforced across the teams of Walmart. Anyone tries to post any data which we believe is sensitive personal information, it won't be shared.
Okay. How do you like this is a bit from the technical point of view. How do you convert the tasks that you have into DAGs while solving problems?
Yes. So let's say you have a join. You have
Mm-hmm.
a really big data set and you have a really tiny table that you want to join with. So
Mm-hmm.
what we do, we either broadcast the smaller table, do a join, we'll see how much compute it's taking on a brute force approach. And if that is taking a whole lot of time, just by using Spark compute, we'll go for alternate options. Like we'll try to go by file basis, because all the tables that we have are just Hive. So just a structure on top of your regular CSV, Parquet, ORC, whatever. So these files we go by spinning up multiple threads. Uh, it can be Kubernetes, just your Databricks, anything. So we'll just go file by file, take each file, join with the table, write the file back. Provided your file is of really good size, 100 MB, 200 MB is a really good size for reading. So when you have these Spark submits, pretty much your class, a Java class or something set in place. So we have something called data proc operator. So that
Mm-hmm.
will get you a small function it will ask you, hey, you know what, give me your jar location, give me your class, and give me where the compute is. So it will stitch it together. So you have one task, and then that section of code, you can just add any number of pieces, and you can just put a double arrow. So that will go from task one to task two. You can split it, saying that after task one, two and three should start parallelly. And if you want two, three to finish before you start four, you can just have task one, a square bracket, task two, three, and then in the below you will just have again task two, comma task three, go to task four. So it will be a diamond shaped structure.
Oh, all of these are configured with?
All in the Python file. So it will be all in the single Python file.
Oh, so
So
you come again?
yes, so your Airflow,
Mm-hmm.
all it needs is a Python file to get the DAG cycle. So you can connect your GCP, anything, Google Cloud, Amazon, or Azure. So what these cloud solutions look for is, hey, you are using Airflow? If yes, they'll give you one blob. If it is Azure, it's a blob. If it's Google, it's a bucket. If it's Azure, it's again a container. So you upload your Python files there. What they'll do is they'll sync up that to Metastore of your Airflow. So every time you upload a Python file, the Airflow will go ahead and check that, hey, you know what, we got a new DAG. So you open the DAG, and it will have a series of steps that have to be executed on whatever schedule you mentioned. So it can be daily, monthly, weekly, a cron schedule.
Okay, so this is apart from, let's say, to achieve a business logic, you write a PySpark code.
Yes.
So PySpark automatically creates a DAG for itself, right? Usually for
So
every expression.
it's not a PySpark. So PySpark, if you have a file, it will again. This Python file is different. So
That's what.
your PySpark is again a way to run your code. So a way to run your code can be different. It can be a shell script, a jar, it can be a war file, it can be a Python file, whatever. So if you want to run these, you will just use different operators when you're running. But the Python file, what I'm talking about is the basic flowchart of your cycle graph. So you have your Python file. In that you will mention, hey, this is my PySpark file. Please run this as part of task one.
Okay, so you're giving the tasks and
yes.
okay. Mm-hmm.
There are various operators, can have environments. So Airflow will give you a basic Python file. So you can connect it to pretty much anything that you can think of. Google Secret Managers. You can have your big scripts running, just your basic shell scripts. You can have echo commands running, just printing stuff. So all you need is a Python file, which your whatever cloud solution you're choosing for will give you a bucket or whatever. They'll connect that to your Airflow. They'll just say, you know what, you upload your Python file here. Airflow will check it every minute, every 15 minutes. It will do a refresh, and that will follow whatever series of tasks you're running.
Is the same approach followed for other cloud services also, like connecting with other services like GCP and Azure?
Yes, yes. What GCP does is whenever you have a storage, so pretty much your compute and storage, Airflow has to detect them. So you will have something called service account. You might have stumbled upon it by now.
Yeah.
So every time you create a service account, you will be given a key. So account key. So what you have to do is in your Airflow, there are something called connections, variables and stuff. So go to connections and you will get a big Dropbox saying that, hey, which of the solutions are you trying to connect to? There'll be FTP, Google, Amazon ECR and all those things. Just select Google. It will tell you, hey, enter your Google project, your service account and your key. Yeah.
What are some of the key challenges in your day-to-day professional?
One is we have a lot of these predictive algorithms. So team is now relying a lot on categorizing which products are configured as health related, because with these new regulations coming in, Washington, Nevada specifically have us asking about sharing what customer health related information we are capturing for customer. So for other states, we have to share everything we got, but for Washington and whatever, we have to share whatever health related information we got. So these algorithms that we get from our AI and ML counterparts in Walmart, so those are performing maybe I can say at 99% accuracy. There are still 1% items that are wrongly tagged as health. So it's pretty much other items that are being shared as health, which are not health related. So it's a little false positive, but we are not undersharing. We may be oversharing. So that is something our team is still working on fixing it. Yeah.
So, like, how often do you work with real-time data? Like, do you ever, like, is it fully on maintaining real-time data, or how do you
Um,
work? What type of data do you work with primarily?
So we have two kinds of things. We have real-time data and batch mode. So real-time data, I can give you an example. We do a lot of customer account events. So whenever a customer is making change to their event, to their account, saying that, hey, this is my new email, this is my new address. Every time that triggers a message and it goes into Kafka. So it depends on which team is monitoring those things and which team wants to maintain the accurate information. So our team as such captures this only for health related preference changes. Like customer can choose not to allow their health data to be shared. So whenever they make changes to those things, we capture part of that event. So it triggers a message in Kafka. So we get that and we maintain a table on that. That's the most real-time data we have maintained. But most of the other teams, they also share the same Kafka topic and to keep up with customers' email, because email is really important. You do a one-on-one mapping on email and then Walmart's IDs, and then you propagate that to more other IDs like your credit card information and whatever. So yeah, that's the one real-time event that I could think we consume. We maintain a copy of it, but rest all, let's say these information the customer raises that, hey, I want to opt out of, let's say, regular marketing emails. I don't want these marketing emails anymore, or I want my data to be deleted. I want my data to be corrected. I just got my last name changed. I want to make this change. So it's not immediate. A customer will be given anywhere from 14 to 45 days time. So in that case, we don't actually need to consume these in a real time. We'll just consume these on a daily basis, even though they're in Kafka. We consume it, we process it, and send it back to the customer back in a week or 10 days. So both the cases we use.
Interesting. What do you suggest, or like what are the skills that are most valuable for big data professionals?
So I started my first project with the Databricks.
Mm-hmm.
Luckily my first role was in Databricks.
Mm-hmm.
Everything what I was doing in MBs or GBs got translated to TBs and petabytes. So
Mm-hmm.
I would say focus on Databricks, go through all of these broadcast things, Bloom filters, check, go through the basics. Like when someone says this Parquet or ORC or JSON, what do they mean by it? Why is it so important? And how much time a team is wasting just to open and close files, because IO is a concept that is lost in all these things. So where do you need write heavy operations? Where do you need read heavy operations? Spark updates their versions often. So right now, our entire Walmart is asked to move to Spark 3. Spark 3 has been there for a while, but since there are too many teams, too many legacy pipelines, slowly it goes, that goes over a year. And even the Spark 2 support has been dropped, I think, 2, 3 months ago. So
Okay.
see what are the changes are from Spark 2 to Spark 3. There are a lot of compression algorithms. So
Mm-hmm.
you have gzip, you have zstd, all of these that are strictly enforced in Spark 3. So
Mm-hmm.
why did they choose to do that? See how you can actually capture or optimize file sizes. See, sometimes you have to choose when you have API open for someone to post data, and they are posting it real time. Every second you get a record. You can't write it to a bucket like a GCP or Azure, because you will end up writing one single file. So it can be anywhere from 1 KB to 10 MB, which are all useless for a file sizes. you need your file size to be at least 100 to 200 MB. It's an optimal file size for any parallel batch execution. So how are current industry professionals handling these scenarios? Are they saving it to a relational database, non-relational database? Are they writing it to file and they have daily compressing jobs and then they send it to ETL? How are they joining really big data on a day-to-day basis? Let's say 12 TB data. You want to join with 2 MB data. How are they doing it? If you have a 20 TB joined with 20 TB, how is it that they are managing? These sort of things. Try to find answers for this. Try to look up online, like what are the changes, what are the new enhancements Spark is providing, what is Hive. Look up BigQuery. So BigQuery is a concept from GCP. Look up Custo. So Custo is a SQL from Azure. So why is every cloud solution looking for their own database kind of models? What are they gaining from it? And they'll again have dashboards, their own dashboards. Azure has Azure Query dashboards. So you can't spend all of your time learning each of these things because you never know which solution your company might end up. So you could be using Google for 10 years, and the day you decide to join after learning whole Google thing, they might just drop all the chances with Google, switch to Amazon. So I would say learn the concepts, learn the basics, learn all these IOs, learn the Bloom filters. Always go for new solutions. Google has something called Achilles. They don't want you even saving your passwords or credentials to retrieve your other passwords. So it's like locking a place and putting the key in another room.
Mm.
So why do you even need a key? So like this service account, they are going for new concepts. So Achilles from Google has clicked up a lot. See where all it is used. Right now, it is only expanded to Kubernetes-based solutions, but anywhere there are these secret managers from these services like Google or Amazon or Azure, they have their own secret managers, and whatever services they are trying to integrate, let's say you have Airflow, they have integration with Airflow. So it's pretty much a workaround, but Achilles is a new concept. So look up what that is. So you don't need any key to unlock things. It'll all be based on your SAML logins, service accounts, and all that stuff. So look up these technologies, see where these are useful. Look up Spark 3 enhancements over Spark 2, and yeah, that's the major things. Always keep up with what new technologies are coming. So all these aggregates that I'm saying, you don't even have to depend it on Looker. Look up Kibana and Elasticsearch. So these are basically indexes where you post your aggregated data. So you might have encountered these already. But yeah, always keep your options open for different dashboarding tools, Tableau. You'll choke up at some point with one of these technologies. Always have one more open. Don't just depend on relational databases. Work with MongoDB, Cassandra, because right now these are the things that we are facing. We are getting charged so much for technology that shouldn't have been used in the first place. So just because some team decided to go with it 10 years ago, we're just stuck with it. So now we are slowly migrating it. It's not an overnight move, but it's a progress every day.
Awesome.
Also, I have one question. So also, as you mentioned just now about the tools like Tableau and Power BI, right? So you are currently using Lookers. So how do you find, I mean, which one do you think is more like in comparison, which one is better? And if you would like to enlighten something on that,
So
or both are same like that.
yes. So if we already have data sitting somewhere, we always prefer Looker.
Okay.
Even though it doesn't go beyond 30 or 60 days, like it'll start to slow down a lot.
Mhm.
So this is about per day 30 TB I'm talking about. So per day
Mhm.
30 TB for 2 months is still better because we are again putting a lot of filters and stuff. But once it goes beyond that, if we are asked to give a sample solution, there is no data, we always prefer Kibana. So just do aggregates, dump everything in Elasticsearch. The
Mhm.
indexes, just write a custom code to dump all this one by one, and then just do dashboards on top of it. That is much better. Yeah.
Do we have any questions?
I mean, I'm good with, I mean, whatever, it was really helpful. I mean, really understood what exactly was going on. So I don't have any further questions pretty
Yeah,
much. So if anyone else
yeah.
has, they can.
I think this session was very informational and
True.
towards the industry
Yeah.
rather than like sitting and studying in
It was
theory.
like he should tell more things. We are coming across more new things. So it was really good listening to you.
Yes, sure.
Yeah, I think we can wrap it up then.
Yeah.
Yeah.
Anything else
Thank you
Yeah,
so
from
much.
Yeah, thank you for your time. It was really
yeah.
informative.
All the best.
Thank
Thank you.
you. Yeah.
Thank you.
Thank you.